Hi, so welcome to today's video lesson, and in today's video lesson we're going to be talking about the dimensions of physical quantities. So physical quantities is both fundamental quantities and derived quantities. So we're going to be talking about the two together. And how do we do their dimensions? One of the things that you have to look at in dimensions is that we're just going to look at three fundamental quantities. We have mass. I'm going to represent that with capital M. Then we have the length. We're going to represent that with capital L, and we have the time. We're going to represent that with capital T. So let's do dimensions for derived quantities. All right, let's start with velocity. Let's start with velocity. So what's the formula for velocity? Velocity is actually distance or displacement. Displacement over time. So it's actually displacement over time, and displacement is measured in meters. That's meters per second. And if that's the case, meters is what's the dimension? Meters is measured in length. Okay, L. Then time, seconds is time. That's T. And so I would say that the dimension of velocity is actually LT raised to power minus 1. So I chose to write it like this. Okay, LT raised to power minus 1. So let's do another quantity. Let's do for acceleration. Acceleration is actually equals to velocity over time. And velocity is actually what? What's velocity? LT raised to the power of minus 1 divided by divided by T. And so if I write that, I'm going to write that as LT to the power of minus 2. So this is acceleration. And remember that the formula for the unit of acceleration is actually meters per second raised to the power minus 2. Okay, good. So it's the same. Length, meters, times seconds raised to the power minus 2. Alright, so let's do force. For force is what? Mass times acceleration. So mass is measured in kg, and we already said that we don't want to do that, so we're doing dimensions. Mass is capital M, right? Capital M multiplied by what's the acceleration? Acceleration is LT to the power of minus 2, and so we have MLT to the power of minus 2. So that's the dimension for force. Then momentum. Momentum is mass times velocity. So mass is going to be m multiplied by velocity. We've done for velocity earlier. That's Lt to the power of minus 1. Lt to the power of minus 1. And that gives us mLt raised to the power of minus 1. Okay, good. That's the dimension for momentum. Then we're going to do two more. Let's do density. Density is actually mass over volume. Okay, so what's mass? Mass is capital M. What's volume? Volume is L to the power of 3. Why? Because length times breadth times height, and length is meters. That's length is L, breadth is length, height is also length. So that's L to the power of 3. And so I'm going to write that as mL to the power of minus 3. So that's the dimension for density. Then we're going to also look at the last one, pressure. So pressure is actually given as, let me write that very well, pressure is actually given as force over area. So force, I think we did for force the other time, that's mlt to the power of minus 2. mlt to the power of minus 2 divided by, what's our area? Our area is actually L squared. Okay, so I think one of these L's, so I can write it as mlt to the power of minus 2 divided by L. So one of these L's is going to cancel out. L cancel L, so I'm left with mt minus 2 over L. So I would rather rewrite this as m L to the power of minus 1, then t to the power of minus 2. So you see the way I wrote that, so I took the reciprocal of that. So this is how to write this is the way to write the dimensions of each of these physical quantities.